Hey guys, welcome back, Mr. Kalkbrenner. I always feel like I yell at the beginning of these things. I apologize. Today's lesson is going to be solving systems of linear equations, elimination style. So last time we talked, it was substitution and checking with graphing, and today is going to be a little bit more of the algebra portion, and we are going to do elimination, which I think a lot of us will like this because it's quick, fast math. All right, so I can, after today, solve systems of linear equations in two variables by elimination, and I can compare and choose appropriate method of solving systems of linear equations based off what is given. Prior knowledge, combining like terms, CLT, x's go with x's, y's go with y's, and constants go with constants. Constants? I don't know if that's a real word, constants. Substituting in ordered pairs, x and y, to check the equation, and finding the least common multiple, the LCM. The goal, take a step back and recognize before you do anything, what is given? Is it given in the order I want it? And line them up, knock them out. Elimination means getting rid of one of those letters. So with that, LCM, least common multiple. So if you recall, what that means is what's the smallest number that they have in common? All right. So I'm just going to list the factors of 2, 4, 6, 8, 10, 12. And then for 8, we have 8, 16, 24, 32, 40. Hopefully after 5 numbers we're there. However, if you look, what is the least number that they have in common? The least common multiple, and that is 8. Notice we have to multiply 2 by 4 in order to get there, and then 8 is just going to be 8 multiplied by 1. So we really don't have to manipulate the 2 there. The 8 there. We have to manipulate 2 by multiplying it by 4. So our least common multiple between 2 and 8 is 8. And now let's do 10 and 3. We have 3, 6, 9, 12, 15, 18, 21. Hopefully we're there. If we're not, we'll just keep going by 3s. It's just counting by 3s essentially. So now let's go 10, 20, 30, 40, 50. Do we see any number that they have in common right now? No, so that means, let's keep going by 3s, 24, 27, and 30. If you look, that is our magical number right there, is 30. That is our least common multiple. That's the least common multiple that they have in common, all right? So just a quick review for what we're going to be doing today. Starting off, Mr. Thomas had this from an old note, and I liked it, so I'm going to use it. And let's warm up this way. We're going to just add vertically. So if you look, this is the X flashcard. What is 3X plus 5X? You got it, 8X. What is 7Y plus 1Y? Positive 8Y. So when you combine those like terms, we're just going to combine them vertically, all right? Before we were kind of doing horizontal in the equations and inequalities that we've done. Now we're going to put them in order by variable. So if you look, what is negative 2a plus 2a? 0a, or just nothing. Now what's 4 plus negative 7? Negative 3b, that's what we're combining. So our final answer would just be negative 3b. And this is a great problem because we eliminated what letter? If this is my final answer, we had a's and b's to start, and now we only have b's. So we eliminated our a values there. And if you notice, we have a negative 2 over top of positive 2. So we have these two having opposite signs, and they have the same coefficient. So that's going to be our goal for today, is this example right here. If you look at C, it looks a little funny. Some of us would get intimidated by this. What does that mean? What do parentheses mean? It means distribute. So I'm just going to recopy the top. And now I'm going to distribute. Take negative 3 times of 2, which is negative 6. X is tagging along. What is negative 3 times negative 1y? positive 3y. Remember, anytime we multiply by a negative, we just change signs. So this was positive, now is negative 6x, and then this was negative y. When you multiply it by negative 3, it turns it into a positive y. So my final answer are going to be those right there, negative 6x plus 3y. We don't combine them because one is an x, one is a y. Modifying equations. So how did I go from this in standard form, right? Because it's ax plus by equals c, right? Ax plus by equals c. Sorry, that's a y. How do we go from this equation to this equation? How do we transform that? Well, let's look at it. If we look here, how do we go from 3x to 6x? We doubled it, right? So my thought right now is we took this whole equation. I saw the word modifying, I like it, but I like the word manipulating, because when you manipulate the situation, you have control of it. Just like this math problem, you actually have physical control over it. And all we're going to do for this problem to modify or manipulate it is exactly that. Multiply each term by 2. Because remember, multiplication went to kindergarten. They learn how to share with everyone. Adding and subtracting, they're not as friendly. They only combine like terms with each other. So x's go with x's, y's go with y's. So now let's go 2 times 3 is 6x. 2 times 2y is 4y, positive 4y. And then double 21, you get 42. So we manipulated the situation by taking this whole equation and multiplying it by 2. All right. The next equation, how do we go from x minus y equals negative 4 to negative 5y plus 5y equals equals 20? What do we multiply this whole left equation by? Well, it used to be 1x, now it's negative 5x. So what do you think we multiplied by? Good, negative 5x. Negative 5 times x is negative 5. I think I misspoke there. We're multiplying it by negative 5. Negative 5 times negative y is positive 5y. And then negative 5 go deep to negative 4 gets us positive 20. So we are manipulating the situation. These numbers were never there. I kind of made them up. But I made them up based off of these values here. And I just doubled 21. I doubled 2y, and I doubled 3x. Here, I multiply by negative 5 because it used to be 1x. Well, how do you go from 1 to negative 5? What's the multiplication process? So it really only takes one number to really figure out the mystery, and then you're going to apply that number to the other values in the equation. We're halfway there. Already, it's a quick lesson. 3 possibilities when solving. Our best case scenario is you line them up. How do you line them up? In standard form, ax plus by equals c. All right, you want the x and the y on the left, the x first, the y term second, the equal sign, and then the constant. The best case scenario is if you line them up and they just cancel out. One of the x's cancels out or one of the y's cancel out. One of the variables, I should say. Option 2, second best case scenario, is you only have to manipulate one of the situations or one of the equations. And the worst equation is when you have to do the most algebra, which isn't so bad because this is algebra class. It's actually 6 multiplication problems. So this is 6 multiplication problems. This is 3 multiplication problems. And then this is just 0 multiplication problems. All right. So it's not that bad. We're asking you to multiply 3 problems or 6 problems. So obviously, the more you multiply, the more mistakes you can make. That's why I call it the worst case scenario. So let's look at this. Best case scenario, you line them up. So here, we're just going to add them up. Best case scenario, what is 4x minus 4x? 0x, or this gets eliminated. Now we have positive 8y plus 2y, giving us 10y. And then we're going to add the constants back here. What is 20 take away 30? Negative 10. Now let's just do that one step solving. And we get y equals negative 1. As you recall from substitution, our answers are always going to be ordered pairs. All right. So the y value is the second of the ordered pair. That's negative 1. So now you have a decision to make. Do I use equation 1 or do I use equation 2 to substitute y back in? I prefer to try to limit mistakes. So I'm looking for the positive equation. That positive equation is the 4x plus 8y equals 20. If you notice, I didn't rewrite the y because I already solved for it. I'm going to substitute back in for that value. So now I'm going to distribute that 8 to negative 1. And I'm going to get negative 8 for my answer there. Equals 20. I didn't do anything to that, so I just recopy that. I'm going to combine like terms over that equal sign. So I'm going to add 8 to both sides because I'm going to isolate that x variable. This gets us an answer of 0. So I get 4x equals 20 plus 8, giving us 28. And I love that number because it's definitely divisible by 4. And I get x equals 7. So my answer for my ordered pair is 7, negative 1. How do you know that's the answer? I can take my answer and plug it in over here and hopefully get negative 30, which is 7, which is negative 1 here. So this is negative 4 times 7 gives negative 28. What is 2 times negative 1? Negative 2. Combine like terms, you get negative 28 minus 2 is negative 30, equaling negative 30, giving us a happy solution. All right. The other thing you can do is obviously use this word right here. And again, we are looking for that POI, that point of intersection. All right. So again, this is just like substitution. It's just a different way of solving. It's a little bit quicker, I think. However, if the numbers are good, like this best case scenario, one falls out right away. Eliminates, I should say, because that's the topic of it. It goes by super quick. Unfortunately, that's not always the case, like this problem here. If I look, I say 2x plus 5y equals 9. That's in standard form. X minus 3y equals 10. If I go to solve this right away, I get 2x plus x is 3x. And I get 5 plus negative 3 is positive 2y. I know something's wrong because I want one of those variables to do what? It's the title of the section. We want one of those to eliminate. So now we have to manipulate one of these situations. All right. When you manipulate something, you have the control over it. All right. So the nicest thing that I can tell you right now is you're going to look to manipulate 1x because you can multiply 1 by to get anything you want it to be. And what's our goal for this problem? It's the opposite of 2x. What's the opposite of 2x? Negative 2, right? So we're going to take this equation and multiply it by negative 2 because I want the opposite of 2x. So I'm just going to recopy my problem up here. And now I'm going to distribute negative 2 to not 1, not 2, but all 3 terms. Short, medium, and deep, all right? What is negative 2 times x? Negative 2x. What is negative 2 times negative 3? Positive 6y. And go deep. What is negative 2 times 10? Negative 20. Now we're going to add vertically. 2x minus 2x gets you my elimination. 5 plus 6 is 11. What am I collecting? My y's. What is 9 plus negative? That's a negative sign. Negative 20 gets me negative 11. Solve for that variable. We get y equals negative 1. And remember, my answer is always an ordered pair. I found the y. And now I'm going to look back at my original problems. and I'm going to choose which one to solve for. It doesn't matter. I'm just going to choose the top one just because I know it doesn't matter, and I just want to prove to you it doesn't matter. 2x plus 5, I'm going to put parentheses for y, equals 9. I'm going to substitute my value in, which is -1 for my y. I'm going to get 2x, and I'm going to distribute that 5 to 1 and get -5 equals 9. I'm going to isolate that variable by doing the opposite of subtracting 5 and adding 5 to both sides, because whatever I do to the one side, I do to the other. I get 2x equals 14. Divide by 2, I get x equals 7. So my answer is 7, comma, -1. I can check that with Desmos again because I'm looking for what? That point of intersection where those two lines cross should be right 7 and down 1. That's what that means. 7, comma, -1. Worst case scenario, you have 5x plus 3y equals 2. Plus 5 or 4x plus 2y equals 10. This means I'm going to have to manipulate both of these situations, all right? So I look at my x values of 5, and of 4, and I can just either solve for x's or solve for y's. I like y's because the numbers are smaller, all right? We're going to use some number sense here and say I like 3 and 2 because they're smaller than 5 and 4. All I'm going to do is figure out what is my least common multiple between 3 and 2. So I'm just going to list factors of 2, 4, 6, 8, 10. Hopefully that's enough. 3, 6, 9, 12, 15. And you can see that 6 is my least common multiple. So I'm going to multiply this top equation by 2 because 2 times 3 gets you my 6. I'm going to multiply this bottom equation by 3. So 3 times 2 is 6. However, I need one of them to be the opposite of 6. So I need the other one to be -6. So I'm going to multiply this one by a -3 to turn 2y into -6y when I multiply by -3. So let's manipulate because we have control of these numbers here. 2 times 5 is 10x. There's the short route. Here's the intermediate route. 2 times 3 is 6y. And then go deep. 2 times 2 is 4. Just like Jarvis Landry went deep to Odell yesterday. Browns, what was it, 49 to 38 or something crazy like that. -3 times 4 is -12x. -3 times 2 is -6y. And then -3 times 10 is -30. And now hopefully we're going to eliminate my chicken scratch of y's here. What is 10x minus 12x? -2x. What is 6 minus 6? Elimination. And I'm going to get 4 minus 30 is -26, which is a weird number, but that's okay because it's divisible by 2. And I'm going to get x equals positive 13. So if you recall, our answer is always going to be an ordered pair. So now I'm going to pick the ones with the smallest numbers. I'm going to pick 4x plus 2y equals 10, and I'm going to plug in my answer to that one, all right? So to get y, I'm going to plug in to that second equation. What is 4 times 13? Let me get my calculator out because I don't know that off the top of my head. That is 52 plus 2y equals 10. I'm going to subtract 52 to isolate that y variable. I get 2y equals -42. And now undo multiplication through division, and I'm going to get y equals -21. So what does this answer mean? Go right 13 and down 21. All right, that's where that point of intersection is going to be between these two values. Are we afraid of big numbers? I don't think so. All right. If you notice, we eliminated y's. We solved for x first, but we can do the same thing if we want to eliminate x's. A quick way to do this, and it might not be the most efficient because the numbers get big, is just crisscross these. 4 goes up high, 5 goes down low. We don't have opposite signs, so I'm going to give that bottom one that negative sign. And now I'm going to distribute short, intermediate, and long, just to show you it doesn't matter what variable you cancel, you're still going to get the same answers. 4 times 3 is 12y. 4 times 2 is 8. Negative 5 times 4 is negative 20x. Negative 5 times 2 is negative 10y. And negative 5 times 10 is negative 50. So you can see that these numbers are a little bit bigger. However, you just take them the same way you did it before. What's 20 minus 20? Elimination. What is 12 minus 10? 2y. What is 50? Negative 50 plus 8? Get you negative 42. Divide by my 2, I get y equals negative 21, which hopefully was my answer back here, which it was. And then we could plug that back in and get my ordered pair of 13, negative 21. However, when in doubt, you can just crisscross these up front and just make sure that you have one be the opposite sign. I always like to make my bottom equation the negative one, just so it's easy to say 20 minus 21. All right? Which system of equations has the same solution as the system below? So you have two equations here. 2x plus y equals negative 3, standard form. 4x plus 5y equals negative 9, standard form. Now we need to figure out which system was manipulated. So if I look at this answer choice, this is delta math. The bottom equation is the exact same, 4x plus 5y equals negative 2. So we know that in all these problems, we must have manipulated the first equation. So how would they have manipulated the first equation in this scenario? How do you go from 2 to negative 4? That's right, multiply by negative 2. What's negative 2 times 2? Negative 4. What is negative 2 times positive 1? Negative 2. Don't forget to go deep. What is negative 2 times negative 3? So this manipulation will look like this. Hold on, let me redo that. It would say negative 4x minus 2y equals 6. So I'm looking for that manipulation, which is right here. All right, so they forgot to distribute to that constant. Here they forgot to distribute to that y term. Here they forgot to distribute to that x. So by process of elimination, we have that being our answer choice. Which option to use? Option 1, best case scenario. Option 2, multiply one of the equations. Option 3, you got both. Which option are we talking about here? It's not 1, because if we just try to add them up, we're in trouble. We get 5 here, and we get 4 here. But if you look, you have 2y and 2y, so we just need to multiply the bottom one by negative 1. So this is an option 2. And I chose to eliminate y's, because when I divide by a negative 1 here, let me just put negative 1 back here. It's going to change and get rid of that 2y to negative 2y and eliminate y's. Here, let's just try adding them up. I get 3x and I get 0y, which is good. So that's option 1. And I chose to get rid of y's again. Here, if we just add them up, we get 15x. That's not good. We get negative 5y. So option 1 is not an option. Option 2, can we multiply something to get, can we multiply 3 by something to get the opposite of 12? So we can take that and multiply by negative 4. What is negative 4 times 3? Negative 12x. What is negative 4 times negative 3y? Positive 12y. And then negative 4 times negative 1 gets us a positive 1. That's going to eliminate our x's. So this was option 2. And we eliminated x. And last but not least, this is going to be, add them up, you get 7x, and we get, oh, so close, we get 1y. We don't want 1y, we want 0y. So option 1 will not work. Will option 2 work? Can I make 2 turn into a 5 by multiplying it by a whole number or an integer? Nope. Can I multiply -2 by something to get 3? Not a whole number, right? Not an integer. So now I like y's here because what do I have set up here? I have my opposite signs. So I'm just going to take this coefficient of y and bring it up here and multiply that equation by it. And then I'm going to take this coefficient, not the sign because I already have the opposite signs, and multiply this whole equation by that. And I'm going to say this is option 3, the most work, which is 6 multiple choice questions or multiplication problems. And then I chose the variable y to get rid of. All right. So this is just a quick little showing of what we're doing. If it's too fast, again, pause it, rewind it, re-listen. Sally has 20 coins in her piggy bank, all dimes and quarters. The total amount of money she has is $3.05. How many coins does she have? If you notice, we have 2 equations for every problem that we've seen. So these word problems are going to have what? 2 equations. Sally has 20 coins. 20 coins equals 20 coins. How much money does she have total? $3.05. All right. Now what do we have to do? We have dimes plus quarters equals 20. Well, how much is a dime? 0.10 D. Plus, what's a quarter? 0.25 quarter. So now that we have our 2 equations set up, we need to do some manipulation. All right. Unfortunately, when we just add these up, we get 1.10 D and we get 1.125 quarters. They don't eliminate. So I'm going to have to manipulate one of these equations. What is the opposite of 0.110? Good, negative 0.110. And now I'm going to have to distribute to those values, and I get negative 10D, negative 0.10D. I get negative 0.10Q because I'm just distributing this deep, intermediate, and then short. What is 20 times negative 0.2 or 0.1? Negative 2. And now we are going to eliminate D's here. Again, the reason why we chose negative 0.10 is because we wanted to eliminate the D's. We could have also chosen negative 0.25 for the Q's, but let's not do that. Let's just stick with the D's. This eliminates here. I get 0.10D plus negative 0.10D, getting a 0. I have 0.25Q minus 0.10Q, so that's going to give me positive 0.5Q. And then 305 minus $2, I get $1.05 left over. How do I get Q by itself? I get 15. Divide by 0.15. And then 1.05 divided by 0.15 gets us 7 quarters. So if I have 7 quarters and I had a total of 20 coins, I'm going to substitute 7 in for Q. Think about it. What number plus 7 gets you 20? We can also do the algebra behind it, and I get D equals 13. So we have 13 dimes and 7 quarters. All right, that's it. Solving systems of linear equations. Again, we have 3 cases. Our best possibility is going to be option 1. Line them up. X over plus by equals C over X plus by equals C. And we don't have to do any manipulation. Second case scenario, we manipulate by doing 3 multiplication problems. And last case scenario, we have to manipulate both of those equations to get that opposite sign, same coefficient. All right, good luck. If you have questions, please email, like, and subscribe. Go Browns.